The next point is surface tension on the basis of molecular theory. This question is very important for a 3 marks. So in that questions or in this point we consider 3 points. Before that we study what is a molecular force of attractions. There are 2 force of attraction, that is a cohesive force, adhesive force is there. So now this point we will study what is a molecular theory or what is a concept behind the surface tensions. Okay, so they are considered 3 points, point A, B and C. Clear? This is a liquid and this is a surface of liquid which is a considered soap film. Okay, so molecule A, molecule B and molecule C is there. Molecular A have some force of attractions. So it produces some force of attractions and it present inside the liquid. Same force is produced by the opposite side and that force is nothing but the cohesive force. So net cohesive force at point A is 0. So for molecular A, the 0 cohesive force or net force cohesive force is 0. Clear? Now consider the second point, that is molecule B. Okay, what is a molecule B? In the molecule B is present at here. Large number of molecules are present in liquid and very few molecules are present on the air. Okay. So because of this, the cohesive force, that is Fc, is very high as compared to the adhesive force. What is adhesive force? Force of attraction between the different material. So this adhesive force, less molecules are there. So this adhesive force is weaker as compared to the cohesive force. So net force again downward, that is a cohesive force. So net force is downward. Clear? Now the third point, that is molecular force at point C, where half molecules, that is the same number of molecules above there, same number of molecules in that liquid. So but we know that density of the liquid is less as compared to the density of liquid is high as compared to the density of air. So density of air is very less as compared to the liquid. Hence again, which force is greater? That is a cohesive force is large as compared to the again adhesive force, and because of this net force is again moved towards the downward. Clear? So this is a main molecular theory. And hence all molecules on the surface of liquid try to pull down to the downward. Hence very few molecules are present on the surface of film. Clear? So very few molecules are there, that's why less area is there. Minimize that surface area. Instead of this type of area, it produces this area, means this area gets stretched down. This area gets stretched down, and that area gets stretched down is called as surface tension. When tension is produced along the surface, that is called the surface tension. Molecular theory suggests that all molecules on the surface try to pull down towards the downward. Clear? Understood? Now the last point is surface energy. And dip into them some foam. Okay, now and connect some movable ring is there, that is a XY stand or ring is there. So this, when you dip into the liquid foam, this XY ring automatically get move upward just because of the surface tension, because we know that molecular theory, this minimize the area of the surface or it reduce the area, all molecules pull towards the downward, so it surface get reduces. Now what is the energy? Means to do some work on it. So we will do some external work on it and again pull down this ring it slowly downward. Pull down this ring it slowly downward by applying some force. Okay, and it travels some distance dx. So we do the work done. What is the work done? Force into some distance, that is a travel. Means what will happen? All the molecules on the surface have very high energy. Instead of the molecules at in the inside the liquid. Means molecule A have very less energy as compared to molecular B and C, which is on the surface, which have very high surface energy. So that's why work done means what? Surface energy. If suppose balloon is there, if we blow the air, its size is this. Again we do some work, its size is this. So what will happen? We do some external energy, so that surface get expanded. So we do some external work. Means it try that to surface that energy. So what is the surface energy? It's a force into displacement. But in terms of tensions, we know that tensions is nothing but force per unit length. Okay. So what is the force? Tension into length. So it's a tension into length. But here the length is xy is a length. Okay. But not a length, it's single because the film have both surface. So we consider this length is 2L. This front side as well as back side. So instead of L, we consider 2L into dx. Okay. What is the formula of area? Length into breadth. So this way, T into this formula is area, that is a dA. And work done means again nothing but the energy. So it's a surface energy. So surface energy is equal to tension into area, or we can know that what is the formula of surface tension in terms of surface energy? That is the surface energy divided by per unit area. So surface tension, now again one more definition, that is surface tension is equal to surface energy per unit area, or surface tension is equal to force per unit length when the imaginary line present on that surface. That is, this force is present here, some same force again present in here. So surface tension is force per unit length, or surface tension is surface energy per unit area. This is the surface energy which travels some work. That is, we have to do some work. That's why this molecule get again spread out. So we can also write surface energy per unit area. Understood? Okay. Thank you. Hope you enjoy this lecture. Please comment me on these lectures and like, share and subscribe this channel. Thank you.